Hypersonic flying is the next significant leap in aviation, enabling speeds faster than sound while leaving no trace other than a loud bang. Imagine reducing the flying time from New York to London to 90 minutes. Elon Musk's SpaceX is reportedly working on a top-secret project that could revolutionize hypersonic travel, while companies like Hermes are pushing the boundaries of what is possible. With Musk's track record of bringing ambitious ideas to fruition, could his latest venture be the breakthrough we've been waiting for? What does this signify for the future of aviation and global connectivity? Join us to discover whether Elon Musk's hypersonic plane defies the speed of light. The pursuit of hypersonic flight is aviation's next frontier, with the potential to transform air travel and redefine global connectedness. While commercial planes normally travel at around 550 miles per hour, hypersonic flying intends to reach Mach 5, which is approximately 3,836 miles per hour or higher. At these speeds, it would take 90 minutes to travel from New York to London, radically cutting existing travel times. Companies such as Hermes, Stratolaunch, and Hypersonics are leading the technological race. However, a startling development has sparked global interest. Elon Musk's SpaceX has unveiled the X-Zone, a groundbreaking UFO fighter plane that defies conventional aeronautical technology. With its cutting-edge technology and unrivaled capabilities, the X-1 promises to revolutionize air combat. It can reach hypersonic speeds of 4,600 miles per hour and uses new camouflage technology to make it practically undetectable to radar. Despite the X-1's apparent primary military design, its propulsion system based on SpaceX's Merlin and Raptor engines improves fuel efficiency by 30% over standard military aircraft. Its scientific achievements have the potential to affect the development of commercial hypersonic aircraft. The incorporation of such cutting-edge technologies emphasizes the changing environment of global aerospace capabilities. These projects face considerable problems, including thermal management, propulsion efficiency, and the development of new materials capable of withstanding severe temperatures and intense heat created at hypersonic speeds, as well as the necessity for specific propulsion systems, are obstacles that engineers must overcome. Despite these challenges, the potential applications of hypersonic technology go beyond commercial travel to include national security and space exploration. The creation of safe, efficient, and commercially viable hypersonic aircraft necessitates advances in material science, aerodynamics, and propulsion technology, whereas routine hypersonic flight may be years of. The continual research and development in this subject are pushing the frontiers of what is feasible in aviation. Imagine a future in which long-distance travel is faster than ever, with the ability to fly across the Atlantic Ocean in less time than it takes to view a movie. For more than 27 years, the Concorde, a sleek and futuristic airplane, fulfilled this goal. This supersonic passenger jet first flew in 1976. It has the ability to reach a remarkable speed of 1,354 miles per hour, surpassing the speed of traditional airplanes. This allowed passengers to fly from New York to London in just under 3 hours rather than the normal 7 to 8 hours. Despite its astounding speed, the Concorde fell short of reaching hypersonic speeds, which began at Mach 5 or 3,836 miles per hour. Nonetheless, it remained a symbol of aviation technology and luxury travel. The final commercial Concorde flight, which marked the end of an era in passenger aviation, occurred on October 24, 2003, before its retirement. Interestingly, the Concorde established a speed record even as it was about to retire. On November 5, 2003, a Concorde dubbed G-Bog flew from New York to Seattle in just 3 hours, 55 minutes, and 12 seconds. The flight was part of the aircraft's trip to its final resting place, at the Museum of Flight in Seattle. However, supersonic flight had its own set of obstacles. Because of noise concerns, many countries, including the United States, have barred supersonic flight over land. This limitation meant that the Concorde could only reach its maximum speed over oceans. The record-breaking New York to Seattle flight required special authorization from Canadian authorities to fly at supersonic speeds over sparsely populated portions of Canada. The Concorde's retirement created a hole in high-speed aviation transport. While it was unable to attain hypersonic speeds, it demonstrated the potential for faster-than-sound passenger flying. Today, A number of businesses are developing new technologies to continue where the Concorde left off, with the goal of making supersonic and even hypersonic travel a reality for future generations. Could a new era of air travel be on the horizon, with travels from New York to London taking just 90 minutes? Hermeus is an ambitious startup. Is working to make this remarkable accomplishment a reality? Founded in 2018, Hermeus aims to surpass the Concorde's achievements by building hypersonic passenger aircraft. Their goal is to develop planes capable of flying at speeds greater than Mach 5, or 5 times the speed of sound. To put this into perspective, the Concorde's fastest transatlantic journey from New York to London lasted 2 hours, 52 minutes, and 59 seconds. Hermeus intends to reduce that time by more than half, offering passengers a 90-minute voyage across the Atlantic. This would revolutionize international travel, allowing for same-day round-trip journeys across continents. Ajay Piplika, the company's CEO, has collected a team of skilled engineers from major aerospace businesses such as SpaceX and Blue Origin. These individuals have considerable experience in the space business, where obtaining rapid speeds is critical. Their united ambition is to apply emerging space advances, such as the recent rise in private space exploration, to the realm of aviation. Hermeus's first step in achieving this lofty ambition is the creation of a prototype aircraft known as the Quarter Horse. The company's unmanned vehicle aims to break speed records and showcase the practicality of its technology. The team's ultimate goal is to outperform the famed Lockheed SR-71 Blackbird. The record for the fastest air-breathing crewed plane still belongs to a reconnaissance aircraft. To accomplish these high speeds, Hermes is creating its own engine, the Chimera. This novel propulsion system combines parts of conventional jet engines with more advanced technologies appropriate for hypersonic flight. The engine's name is a reference to the fire-breathing monster from Greek mythology, representing its powerful and hybrid characteristics. Hermeus faces enormous obstacles in its pursuit of hypersonic passenger flight. These include dealing with the severe heat produced at such high speeds, guaranteeing passenger safety and comfort, and resolving any environmental issues. Furthermore, they will have to traverse intricate restrictions governing supersonic and hypersonic flying over populous regions. As Hermeus's technology advances, routine hypersonic travel becomes more feasible. While it will be some time before scheduling a 90-minute journey across the Atlantic is possible, companies like Hermes are pushing the limits of what air transport can do. As individuals dream of flying faster than before, one question arises: how can engineers create an engine powerful enough to achieve hypersonic speeds? Hermes' ambitious aim to construct hypersonic aircraft revolves around a breakthrough engine known as Chimera. This engine, named after the fire-breathing monster from Greek mythology, depicts a fusion of multiple technologies, just as its mythical name combines parts from several animals. We classify Chimera as a turbine-based mixed-cycle engine. This suggests that it integrates the best features of different jet engine types to surpass their individual limitations. The 3 main engine types used are turbojet, ramjet, and scramjet engines. Turbojet engines power the majority of today's commercial aircraft, work well from a standstill to almost twice the speed of sound, which is Mach 2. However, they find it difficult to maintain speeds above this threshold. Ramjets and scramjets, on the other hand, excel at extremely high speeds, particularly above Mach 5, but they are inefficient at low speeds or at rest. The Chimera engine intends to close this gap by using a turbojet for takeoff and initial acceleration before transitioning to a ramjet mode for high-speed cruise. This combination enables the aircraft to take off from conventional runways, accelerate to hypersonic speeds, and then sustain those speeds for lengthy periods of time. Hermeus adopted an unusual method for developing this sophisticated engine. Instead of starting from scratch, they used commercially available gas turbine engines for the initial turbojet component. This method saved them billions of dollars in development expenditures and many years of work. Hermeus picked the General Electric J85 turbojet engine to power their first Chimera prototype. Several aircraft, including the Cessna A-37 Dragonfly and Northrop F-5 fighter, have used this engine for a long and successful history. The J85 has accumulated more than 16.5 million flying hours, demonstrating its dependability and capability. Hermeus reached a critical milestone in November 2022 by successfully transitioning from turbojet to ramjet mode in its Chimera engine. This transition is critical for hypersonic flight because it enables the engine to run efficiently at a variety of speeds. Hermes built on this accomplishment by inventing Chimera II, an enhanced version of the engine. The more powerful Pratt & Whitney F100 engine provided the turbojet core for Chimera II. Well-known fighter jets like the F-15 Eagle and the F-16 Fighting Falcon use the F100, which has accumulated over 30 million flying hours in service with air forces worldwide. While Hermes used existing engines for the turbojet component, they designed other critical components of the Chimera engine in-house. These include the inlet, pre-cooler, ram burner, and bypass system. These components are critical for dealing with the high temperatures and pressures encountered during hypersonic flight. An improved cooling system is one of Hermes's most important technologies. At hypersonic speeds, friction causes the air entering the engine to become extremely hot, which can damage the engine components. The pre-cooler technology helps regulate the heat, allowing the engine to run safely at high speeds. In May 2024, Hermes began testing its patented cooling system with the F100 engine, which was a big step forward in Chimera II development. Early testing predicts that this cooling mechanism will enable the engine to reach speeds of up to Mach 2.5. The creation of the Chimera engine poses a significant technological hurdle. Combining many types of jet propulsion into a single efficient system necessitates solving complicated technical challenges involving thermodynamics, material science, and fluid dynamics. However, if successful, this engine has the potential to transform air travel. Hermes' engine development approach, which combines off-the-shelf components with custom-built technology, has resulted in quick progress. They built and tested their first Chimera engine for only $18 million over 21 months. Creating breakthrough aeronautical technologies often requires a fraction of the time and money. As Hermes works to modify and test the Chimera engine, they get closer to their objective of hypersonic passenger transport. While there are still many obstacles to overcome, the progress they've achieved with Chimera shows the potential for huge breakthroughs in aviation technology. If successful, engines like Chimera might usher in a new era of super-fast global travel. There will be a dramatic reduction in long-distance flight times. As Hermes builds its groundbreaking Chimera engine, one may question how they intend to test and prove this revolutionary technology in real-world scenarios. Hermes's ambitious goal of developing a series of increasingly improved planes to demonstrate hypersonic capability provides the answer. The quarter horse is actually a family of prototypes rather than a single aircraft. Each aims to slightly exceed the speed and performance limits of its predecessor. A unique form of the quarter horse Mach 0, Mach 1, Mach 2, and Mach 3 represents each of the four major stages of the project. Look at each level and its impact on hypersonic flying. The adventure begins with a quarter horse Mach 0, a ground test vehicle, which is designed to evaluate various systems. Their integration takes place prior to the actual flight. Early in 2024, Hermes announced the completion of Mach 0 testing at the Air Force's Arnold Engineering Development Complex in Tennessee. During these tests, the Mach 0 reached several significant milestones. The team demonstrated the capacity to control the vehicle from a distance, which is critical for future unmanned missions. The Mach 0 successfully moved on the ground to simulate pre-flight activities. They evaluated the speed and reliability of communications between the vehicle and ground control, as well as the vehicle's ability to move on the ground. The crew confirmed that the vehicle's equipment worked properly under simulated flight conditions, and pilots performed simulated flight operations to ensure that the vehicle's controls were intuitive and effective. Hermes designed and manufactured the Mach 0 in 6 months and completed all tests in 37 days, which is extremely impressive. This rapid development cycle exemplifies the company's agile approach to aeronautical engineering. Following the success of the Mach 0, Hermes introduced the quarter horse Mach 1 in March 2024. This version is set to take to the skies, with the first flight expected for late 2024 from California's historic Edwards Air Force Base. The Mach 1 is a remotely piloted vehicle, which means it can fly without a human on board. Its primary goal is to demonstrate high-speed takeoff and landing skills, which are required for any future hypersonic aircraft. These tests will serve to demonstrate that Hermes technology can operate securely and successfully in real-world scenarios. Like its predecessor, the Mach 1 underwent rapid development, taking only 7 months from design to completion. This rapid iteration enables Hermes to learn and improve their designs more quickly than traditional aerospace development cycles. Both the Mk0 and Mk1 use the Chimera engine, which is based on the General Electric JD5, providing a stable platform for testing the company's novel propulsion concepts. The Mk2 is the next step in the quarter-horse project, and it will use the more advanced Chimera 2 engine. This engine's core is the Pratt & Whitney Phone 100, which provides much greater power than the J85 utilized in previous versions. In May 2024, Hermes began testing its own cooling technology with the F100 engine, which marked a significant milestone in the Mk2's development. This cooling mechanism is critical for regulating the tremendous temperatures produced during high-speed flight. The goal of the quarter-horse Mk2 is to demonstrate autonomous supersonic flight at speeds of up to Mach 2.5, or roughly 1,918 miles per hour. This would be more than twice as fast as the Concorde's cruise speed, marking a huge step toward hypersonic flight. The quarter-horse project's final intended iteration is the Mach 3, which symbolizes Hermes' most ambitious objectives. With this iteration, the company hopes to show the shift from turbojet to ramjet mode in flight, which is necessary for reaching hypersonic speeds. More importantly, Hermes believes the Mk3 will break the legendary SR-71's all-time airspeed record. In 1976, the Blackbird, a spy aircraft constructed in the 1960s, established a speed record of 2,193 miles per hour, equivalent to Mach 2.85. This record, which has stood for nearly 50 years, demonstrates Hermes' significant struggle to achieve the ultimate goal for the quarter-horse Mach 3. The goal is to reach Mach 4, which is approximately 3,069 miles per hour. While this falls short of the Mach 5 criterion for hypersonic flight, it would be a significant advancement in aviation technology, bringing Hermes much closer to their goal of hypersonic passenger travel. The quarter-horse initiative is exciting, but it confronts significant hurdles. Friction with the air produces significant heat at high speeds, which can harm the aircraft. Creating materials and cooling systems that can endure high temperatures is critical. The Chimera engine must be efficient over a wide range of speeds, from takeoff to hypersonic travel. Careful planning of the aircraft's shape is necessary to reduce drag and control shock waves at high speeds. High-speed flight takes tremendous amounts of energy, therefore fuel efficiency is an important consideration. The noise and pollution from hypersonic aircraft may meet regulatory challenges. Any passenger aircraft must fulfill extremely high safety standards, which become increasingly difficult at hypersonic speeds. Despite these limitations, Hermes has made significant progress. Their capacity to quickly develop, build, and test new prototypes enables them to iterate and enhance their technology. They have been able to advance their project more quickly thanks to this agile methodology and their creative use of off-the-shelf components. The approach is also more economical compared to traditional methods for aerospace development. While Hermes has not established a precise time frame for the Mk3's record attempt, their rapid development rate suggests it could take place within the next few years. The corporation is regularly monitoring production deadlines and the team's ability to meet goals. With Hermes making remarkable advances in hypersonic technology, what does the future hold for this ambitious startup? Hermes has received tremendous backing from major groups and individuals. NASA, the US Air Force, and OpenAI co-founder Sam Altman have all made investments in the startup. This support, worth hundreds of millions of dollars, illustrates these entities' belief in Hermes' vision and promise. NASA and the US Air Force endorse Hermes' technology, which suggests potential applications beyond commercial flying. Hypersonic aircraft may have significant ramifications. In terms of national security and space exploration, Hermes has both great potential and major problems in the future. The company's lofty objective of breaking the SR-71 Blackbird speed record by 2025 will be a critical test of its technology. If successful, it might open the path for further advances in hypersonic travel. However, Hermes must address concerns about the environmental impact of hypersonic flying, as well as the safety and comfort of future passengers, and understand the intricate international restrictions governing supersonic and hypersonic flights over inhabited regions. Despite these challenges, Hermes' significant investment and rapid advancement suggest a promising future for hypersonic travel. If their ambitions come true, we may soon witness a revolution in long-distance air travel. Thank you for watching. While you're here, click the link on your screen to view another of our videos. See you there.